Alright, in part 1 of our tutorial series, we're going to be talking about the balking pattern. So what is the balking pattern? The balking pattern describes an object that only executes an action when it's in a particular state. If the object is not in the correct state when the action is invoked, the object will log an error, throw an exception, or balk in some other way to indicate that this happened. So let's take a quick look at a diagram here. So not much going on, just one class, state variable, a few methods. I think if we look at the code, it'll be a little bit more descriptive. So pop up Eclipse here. We've got our status variable here with a couple different states, not ready, ready, busy. We've got a make ready method that sets our status to ready. We have a perform action method that if the status is not ready, it balks and prints out this error message. If the status is ready, we set the status to busy, perform the action, in this case just print out something, and then call the action complete method, which will update the status variable back to ready. Alright, let's take a look at this test case here. So in this case we've got, creating two threads here. Thread number 1, when it starts up, it immediately tries to perform the action on the balking object and should fail because it's not in the ready state yet. Meanwhile, thread number 2 starts up, calls the make ready method, and then the perform action, so that should work. Back to thread number 1, we've got a thread.sleep here, so after that it does a second attempt, which should succeed because thread number 2 called make ready, so the object should now be in the ready state. So let's go ahead and start this and see how it runs. So, alright, looks like case number 1, thread 1 failed correctly, that's what we expected. Thread number 2, success case, worked, it's not balking, and the second attempt in thread number 1 also worked, not balking. Okay, well that's what we expected. Alright, let's look at this example application. Basic car drive-by-wire control application. So we're going to need a car object, we're going to need a method to start the car's engine, a method to accelerate the car and move it forward, a braking method to slow and stop the car, a state variable to keep track of the car's status, whether it's off, running, accelerating, braking, and an action complete method to update the state after we've been accelerating or braking. Okay, here's a UML diagram of our application. We've got a car object here with our status variable, a speed variable, start, accelerate, brake, action complete methods, and we have a test car class here where we execute our test cases. So let's jump over to Eclipse here and look at the code. Alright, here's our car class here. We've got our state type here with our different running, not running, accelerating, and braking states. Our state variable, which has our object's state. A start method to start the car. An accelerate method that if the car is not running, it will balk because you can't accelerate if your car is not on. If it is on, it will accelerate. We've got a braking method here that if the car is currently accelerating, it will balk because you shouldn't be accelerating you shouldn't be braking while you're accelerating because that will cause premature brake wear. Otherwise, it brakes, it slows the speed down, and we have the action complete method here. Okay, let's take a look at our test class here. So, two threads here. Thread 1. Driver number 1, we'll just pretend this is like a driver's ed situation. So driver number 1 just tries to accelerate the car without starting it first, so that should fail. Then there's a sleep here and then a second attempt. So meanwhile, in thread number 2, start the car, then accelerate. So that should work. That should be successful. Then we have a thread sleep here. A little while later, we will try to brake the car, which should also work. Okay, let's take a look at this running and see how it looks. Okay, let me just expand this a little bit. Alright, looks like a fail case in thread number 1 failed as expected, and then case number 1 in thread 2. This is driver number 2 starting car and accelerating. We got ignition success and accelerating to 10. Okay, back to thread 1. Driver number 1 tries to accelerate now that the car is running, so we accelerate to 20. Then back in thread 2, after a while, driver number 2 applies the brakes, so we brake back down to 10. Alright, that looks good. Okay, let's talk about some of the implications, some of the pros and cons of this pattern. So the pros, simplicity. It's a very simple pattern. It also puts the onus on the developer to ensure the correct state before invoking an action. There's less runtime checking or trying to compensate or recover. If it's in the wrong state, you just simply don't do it and throw an error. Cons, sensitivity to timing. You know, if you had some sort of critical application where you needed to be sure that something happened, this wouldn't be a good pattern for that. Because of that, these potential timing sensitivities is you could be coding to an implementation, and a lot of people have referred to this as an anti-pattern, because if your class can't support its API all the time, then maybe there's issues with the API. Maybe it should be written in a way so that the methods aren't available if the object's not in the correct state, or maybe even wrapped with a facade pattern to always return a good object that is in an end state. Okay, that's the end of the Balking pattern. So check back for part number 2. We're going to be talking about double checked locking.